Anyway, that's big O notation. Again, it's not testable, but it's good information to know. So now let's talk about selection sort. So let's go back and look at some of those sorting methodologies that we talked about. Now, if you remember from the video on the website we were looking at, the selection sort was pretty terrible, right? The speed of it was terrible. But one of the great things about selection sort is that it is super easy to implement. So let's take a look at the code. So let's take a look at the selection sort algorithm, since it's one of the more basic ones. And here's the algorithm. For I equals 0, and while I is less than the list length, we're going to increment I, right? So we're going to go through the array. Then we're going to find the smallest value in the list from list I, right? So we're starting at index. So if we say we're starting at 0, we're going to go from the beginning and we're going to work our way to the bottom of the list, and we're going to swap the value that we found with that item, right? So here's what it looks like, right? So we start at 5, and we go down the list, and we're going to search for the entire array. And then we're going to keep track of where the smallest element was. And once we find the smallest element, we're going to move it up. We're going to swap these positions, right? So you can see the result of the swap here. So then we're going to go with the next iteration. We're going to go to I, plus 1. We're going to I plus plus. We're going to increment, and we're going to start here, and we're going to go down and find the next smallest value. And we're going to swap those, right? And then the result of that you can see here. And then we're going to do it again. We're going to go down, and we're going to swap. Well, 5 is the smallest, so obviously we really don't need to swap it. And we're going to iterate again. We're going to start here, and we're going to see that we're going to swap these two elements, right? Because 10 is now the smallest. And now we're done, and we have a sorted array. So that is selection sort, and it's one of the easiest to implement that you can find. All right, so let's take a look at it in code. So here we have the class sort, and we have a method called sort, and we're going to pass in an integer array. So int j is going to be the index of the smallest value, right? And so for I equals 0, why we're less than the length minus 1, and we're doing minus 1 because once we don't have to go all the way to the end. We have to go to the one before the end because we're going to look ahead. And once we get to that one, by the time we get to there, the last one is guaranteed to be the smallest element. So we don't have to check the last element, right? And so j is equal to index of next smallest. And we're going to pass in the list, and we're going to pass in I. And then we're going to swap I and j and that list. So if we come down here and we look at index of next smallest, we pass in an array and we pass in the starting index, right? And we say, okay, wherever we're starting at is the smallest number. And for where we're starting at to the end of the list, we're going to go through, and if the list is smaller than our smallest one, then we're setting our minimum index to I, and we're going to return the minimum index once we've gone through it all, right? So this minimum index is going to come back up to here, and j is going to be assigned to whatever that value is, and then we're going to swap I and j in our list, right? So just like the pseudocode said to do, right? So that's how you can implement selection sort in code. And it looks a little bit more confusing here because we actually have a separate method for both swap and the next index, but this could all be collapsed into one single method, but you don't have to. So insertion sort is similar to selection sort, but it's a little bit different. So what we're going to do is for our array, for its length minus 1, we're going to go through it, and we are going to store our next item in line's value. And then we're going to iterate through the entire list until we find the smallest value. And then what we're going to do is we're going to shift everything down one by one. And you do this when you're playing cards. Say you're holding a deck of cards and you're arranging your hand to go from smallest to largest, right? What do? You go through it and you pick up your card and you say, okay, I've got a two of diamonds. Well, I'm going to pick my two of diamonds up and move it all the way to the left in my hand. And then all the other cards are shifted to the right. Well, in programming with an array, you do the same thing. Is you are going to find a card and you're going to look at the card and see if it's smaller. And if it is, you're going to pull it up and you got to shift everything to the right first before you can put it back in place. So let's take a look at this in actuality. Right, so here is our array of items. We've got 5, 10, -3, 20, and 2. So our orange line right here is I, and our green line is J. So if we look at this, temp is going to be set to our list of I plus 1. In this case, it's 10. J is going to be equal to I plus 1 as well. While J is less or is greater than 0, and our temp value is less than our list J minus 1. In this case, it's, so in this case, what this would be is temp is equal to 10. And if temp is less than our list, our J index minus 1, then we are going to swap the positions, right? We're going to take our list at J, 10, and we're going to swap it with the one before it. And then we're going to decrement J. We're going to go up. In this case, it's not, so we're going to skip that. And we go on to the next one, right? So now we're at I is 1. And so temp is equal to list I plus 1, so it's -3. And J's is equal to I plus 1, so J is equal to 2, right? So right here, J is greater than 0, and our temp value is -3. So it's less than the position before it. So what we're doing is we are going to put our list at J minus 1. We're going to move this 10 down to where 3 is at, right? But we're storing the -3. We put it in the temp variable. Right? And so then we're going to decrement J, and we're going to do the same thing. So what does that result in? Well, it results in 3 getting moved all the way up to the top, and 10 and 5 being moved down 1. And then we're going to do the same thing. We're going to go down and say, okay, is 20 less than anything before it? No, it's not. So that's really not going to have any effect. But now we move to 2, and we can see that 2 is going to be pulled out. 2 is going to be stored in this temp variable, right? And then while the J index, this green arrow, is greater than 0, and the temp variable, which in this case is 2, is less than the position before the green arrow, we're going to move it up. Well, actually, we're going to move this down, we're going to move this down, we're going to move this down, and then we're going to drop 2 in here, right? And that's what all of this does, and that's what this last one does, right? It's going to say when we're done, we're going to get to here, and we're going to say, okay, we're done. We need to submit it in. And so that's what's going to end up with our final list. So again, it's really, really complicated. I mean, it's not really complicated, but it's really hard when you're looking at just these index and arrays and everything to figure out what's going on. So it really helps to draw this stuff out with pen and paper and say, okay, at each step of the array, what's going on? What's happening? What is moving where? And it will help you figure this out. So here it is in code, through the author's code. And we have an insertion sort, right? We're passing in an array. And of course, it's static, so it's a class function. And for each item, notice how he's labeling it. Item to insert is at list I. And for list J equals I, so we are initializing J to be equal to I, and J is greater than 0, and the item to insert is less than the item before it, then we're going to, that's the condition for the loop to continue, then we're going to move the item up, right? So we're going to say the list at index j is going to be equal to the item at j minus 1. So whatever came before it is now moved right in the array, right? And then so it's going to loop through all of those as long as those values are greater than the one that we're looking at, right, which is smaller. So once we get done moving all those things to the right, which is, this is what this loop is doing, then we're inserting this item at list j, and that's the point that we stopped, right? So here we have an array, and we are going to populate it with 19 things, and we're going to randomize it, and then we're going to sort it. So let's go ahead and take it for a test drive and see what we get, right? Right, so there's our initial array, and there's our final array. You can see that it's in fact sorted. So proof that it works, right? Pay attention to how the pseudocode that we wrote isn't necessarily exactly the same. We combine some steps, like, right? So in our for loop header, this might be some new stuff to you. Here we didn't declare int to be equal to, or in I to be equal to 0. Here we're saying, hey, j is going to be equal to whatever I is. So we're starting through the list, right? And that's just an optimization just to kind of reduce the runtime of it a little bit, right? But notice also this conditional. Notice how we have, in fact, a multi-part conditional in our for loop, and you can do that. This is what tells the loop to continue running, and this is what happens at the end of the loop. We're going to decrement j. If this condition is false at any moment, the loop stops running, and that's executed at the top of the loop. So it's important to remember these things, right? So bubble sort is another extremely simple algorithm to implement. So we're going to take a look at it. We're not going to look at it in code. We're just going to look at it in theory, because we actually take a look at it in CS225 when we do some C++ work. So I'm going to save the drama for then. But for now, let's just go ahead and take a look at how we implement it in. Okay, so bubble sort's a little similar to insertion sort, but like all of them, it's got its own little variants, right? So for each item in the list, or for the list, we're going to iterate through it a second time, and if the item is greater, or excuse me, is less than the item that came before it, we are going to swap them. So what does that look like? Well, so here we have our index pointer right here marking j, and this is where we have to stop, right? So we're going to go through the list, and we're going to look at, okay, is 10 less than 5? No, it's not. It's greater than, right? So then we move down one. Is 3 less than 10? Yes, it is. So we're going to swap those two, right? So we move -3 up, but then we keep progressing down the list. Is 20 less than 10? No, it's not. So we don't do anything. Is 20 less than 2, or is 2 less than 20? Yes, it is. So we're going to swap 2 and 20. So what we've done, in effect, is we've made the highest number percolate all the way to the top of the list, right? Because remember, this is 0 and this is the highest number. So 20 has made its way all the way to the top. So it's bubbled up to the top. So now we start here again at the next index, and then we're going to iterate through the whole thing again. So we're going to start at 1, and is this position less than the one before it? Well, yeah, it is, right? So it's going to get swapped. Is 10 less than 5? No, it's not. So we move down. Is 2 less than 10? Yes, it is. So we swap them. So now 10 is the second highest number, and it's bubbled all the way up to the top -1 position. And we go back through again. Is 5 less than 3? No, it's not. So we move down. Is 2 less than 5? Yes, it is. So we move up. And then we're done, because we're sorted, because we've gotten to the list as lengths minus I, right? So that's how bubble sort works. the smallest or largest numbers percolate to one side of the list or the other, depending on how you have your evaluations done. Okay, I said I wasn't going to do it, but we'll do it. Whoops, update my comments here. So here's the bubble sort algorithm, and basically all I did was copy the insertion sort class. That's why I'm updating the comments now. Bubble sort, right? So basically all we're doing is we've got an array of length n, and we're setting our temporary variable to 0. And we're going to go through for int I, we're going to loop through the array's length, and for j, we're going to loop through it while it's less than the length minus I. That's just an optimization. We could go to the end, but there's no need to. And if the array at position j minus 1 is greater than the array at j, then we're going to swap it, right? And so here's the swap algorithm. You've seen that before. And that's all it is. So if we save it and we go ahead and run it, there you go. So you see our initial array is all crazy and cattywampus, and here we go is our fully sorted array, right? The rest of the code down here was the same as insertion sort. It's just we're filling up an array with variables of random whatevers, and then we're just printing them out nice and pretty, and that's it. So that's bubble sort.